Now I'm going to go over proportionality rather briefly because I can refer you back to an MBE 61 class where I did it. Not practically the same thing I'm going to say here. I said pretty much everything needs to be said. But just to be sure. Okay. AROP for proportional to X means that Y equals KX. What would the graph of Y equals KX look like? Can you tell me what the slope would be? Well, the slope intercept form is Y equals MX plus B, right? Where do you see M? It's the coefficient of X, right? So the slope would be K. What's the Y-intercept? If this is a Y equals MX plus B, what's the value of B? Can you show me with your fingers? 0. There's no B. Which means that the Y-intercept is at 0, which is the origin. Okay? So it's just a straight line through the origin. So I'll just kind of sketch that. There's your Y-intercept, and your slope is K. That's a useful connection, although you're going to be able to solve most of the problems without using that, but it's useful to know this. Okay, that's a direct proportion. Okay. Now we have direct proportion, we have inverse proportion. Means Y equals K divided by X. Well, just to, again, put it in the context of something we know already. If I was to do a graph of this, K over X is K times 1 over X. So you vertically stretched the toolkit reciprocal function. There's your toolkit reciprocal function, just multiplied by K. So it's going to have a graph that looks just like the graph of the toolkit reciprocal function. Okay? That makes sense? Now, it's only in the first quadrant because we aren't going to use negative numbers with proportionalities, although we could generalize it to that, but we're probably not going to see that. In this case, if X gets bigger, does Y get bigger, smaller, or can't you tell? Bigger, smaller, can't tell. In this case, if X is bigger, is Y going to be bigger? Or is it going to be smaller? Going to be bigger. You see that in the graph. You know, X gets bigger, Y gets bigger, right? Or you multiply an X by some number K. If you multiply a bigger number by K, you're going to get a bigger value, right? So we can say one characteristic of a direct proportionality is bigger X implies bigger Y. It's not a mathematical statement. I have to use the word greater and less. So, okay, I'm still going to use bigger because it's more intuitive. All right. We'll go something. Okay. Y equals K over X. Well, you're dividing K by X, right? So if X gets bigger, does Y get bigger or smaller? It gets smaller because you're dividing by a bigger number. The bigger number you divide by, the less you're going to get. And also the graph. X gets bigger. As X gets bigger, you follow the curve along like this, and Y keeps getting smaller. Again, greater or lesser is the better word mathematically, but trying to stay sort of intuitive here. Okay, so we say directly proportional. It just means that if X gets bigger, Y gets bigger, but linearly, like along a linear graph, along a straight line graph. Okay. Inversely proportional means a bigger X implies a smaller Y, and you're going to be dividing by X, so you have this 1 over X behavior. Okay. Now, how do you use proportionality? Well, here we go. If X is inversely proportional to Y, and Y equals 12 when X equals 3, then what does that tell you? Not quite. If it was directly proportional, you would get that. It's inversely proportional. That means you have Y equals K over X. Now, if Y equals K over X, what can you do? You can plug in the value of Y and you can plug in the value of X. Okay? Y equals K over X, so 12 equals K over 3. Now, take a second and solve that for K. Okay, so what's the step we take? We multiply both sides by 3. We just do this automatically. When we see denominators, we get the heck rid of it. Okay, if we possibly can. So we do 3 times 12 equals 3 times K over 3. 3 times 12 is 36. That's 3 over 3, which is 1 times K, so K equals 36. Okay. I'm going to ask you a question you might not be able to answer because there's an assumption here that I'm not going to make clear until I do. I'm going to ask you a question. I haven't shown you the step you need, but maybe you can answer. Okay, let's get the question you got. What would Y be if X equals 9 instead of 3? Okay, y'all did pretty well with this. Okay, there's a process you want to follow. You don't want to just directly start answering this. First, you do this. This is an important step. Now we know that Y equals 36 over X. Because Y equals K over X, we figured out what K is, and this will be the correct equation anytime we have this particular inverse proportionality. Okay. So rest is quite simple. And once you have this equation, you can plug any x value in and get the corresponding y value. Tells you when x equals 4, y equals 9. An example that this would correspond to, I'm trying to come up with realistic numbers here because I didn't do that at the start of. Meaningful interpretation. Hours. It takes, well, to get there at 3 miles per hour. Okay, not where, I don't know, just a sum. Okay. So you're walking 3 miles per hour, you're going to be walking 12 hours. Okay. To do the same trip at 9 miles an hour, it takes 4 hours. Because the faster you walk, the quicker you're going to get there, right? And what you're doing is you're walking 3 times as fast, you're going to take 1/3 as long. 9 miles an hour is 3 times 3 miles an hour. So 12 miles an hour, you're going to get there 3 times as fast. 12 divided by 3 is 4. Now you could work it out that way. But in general, now we could put any speed into this relationship here, into this function, okay? And figure out how long it's going to take us. Now it's a pretty simple example, it's a pretty simple situation. Okay. I don't like to block the board if I can help it. I don't do that too often. This board's kind of long, so I'm going to flip it. Okay. Now, here's a situation. Y is inversely proportional to x to the square of x. As I said, to x squared. And y equals 100 when x equals 5. Now just read this upside down. Well, it says if y is proportional to x, then y equals k over x, right? What do you think it would be? For an inverse proportion to x squared. Jot it down if you think, if you got an idea. If you don't, that's okay. I'll show you. Okay, some people got it, some people didn't. Comes out pretty simply. Okay, If y is inversely proportional to x, it's y equals k over x. If y is inversely proportional to aardvark, what's your rule? Be y equals k over aardvark, right? And if aardvark happens to be x squared, then it's y equals k over x squared. K over whatever y is proportional to. Does that make sense? I'm sure it does to a lot of people, because a lot of people got it. Not everybody did, and several people didn't. Probably thinking it before I to write it. Okay, since y equals k over x squared, so 100 equals k over 5 squared. Be k over 25. K is going to be 2,500. As soon as you get k, you write out your proportionality for the exact situation, for the specific situation. There's your proportionality. Now, if x equals 20, what's y? What have I done? Okay, get out of there. Okay, well, 20 squared is 400. 400 goes into this 6.25 times. I want to write that 6. There it is. What you got? Might have used a calculator. Another way to figure that out is 20 is 4 times as big as 5. If you square 4, you get 16. And 100 divided by 16 is 6.25. Everybody knows that. Okay, well, no. Okay. Makes sense? So it's pretty simple. The whole scheme is very simple, but you want to follow the sequence of steps that I've outlined here. You write the proportionality. Here. Plug in your known values, which we did here. You rewrite the proportionality, and then you plug in new values and solve. There's 4 steps. I recommend you take a minute to jot them down somewhere where you'll see them and just follow those 4 steps. Don't skip any steps until you really are used to the process, and think about what the process means. So we're going to start by constructing a graph of the toolkit. Absolute value. Okay, so this kind of got that down, probably doing a 4x4 square. Although pretty easy to do any old way. Okay, that's mainly wanted to see how much explanation I'm going to have to give. Okay, so what I saw, I'm going to do this. The red dot in the center. Not sure I did it this way before. Meaning the x-axis goes this way, and the y-axis goes this way. Those are the only lines you need. And here's your graph. Okay. And to confirm this, what are the coordinates at this point? Show me x coordinate, y coordinate. Okay. Can't see how many fingers you got in that other hand. Okay. Okay. Okay, remember this is a 4x4 rectangle, and the origin's here. So the question is, how far do you have to go over and how far do you have to go up to get to this point? 2 and 2. Okay, some people have 4 and 4. Some people have 2 and 4, which is what you get if you have the red dot down here. You went all the way up to this corner, but then it wouldn't be the absolute value function. It would be 2 times the absolute value function. Okay, so if we do it like this point is 2, 2, and then you're going to tell me this point is negative 2, 2. I want to ask you to signal that because you need 3 hands, one for the minus sign, one for the 2, and the other for the other 2. Okay. And of course, we got the origin at 0, 0. Now we know what that is. Okay, now is this correct? You want to check if 2, 2 is right. The absolute value 2 equal to 2? Well, yeah. Yep. And is absolute value negative 2 equal to 2? Oh, yeah, absolute value is just magnitude of the number. From the number lines, how far you are from the origin. Okay. So there we go. Okay. So you can estimate the absolute value of any number, but you know what it is anyway. Okay. It's just going to be a number with any negative. I'm going to go different route, and then we'll pull this route together with this route. Okay. Solve these equations. Absolute value of x equals 12. And the absolute value of x minus 3 equals 12. And then the absolute value of 2x plus 5 equals 12. To solve the first one, you just got to give me every value of x whose absolute value is 12. Okay. Absolute value of x equals 12. True for x equals 12, also for x equals negative 12. So your solution set is a set of numbers negative 12 and 12. And you want to write it out as a solution set, okay? And the set braces are 4, okay? Okay. Now, absolute value of x minus 3 equals 12 is true if x minus 3 is 12, isn't it? If x minus 3 is 12, then the absolute value of x minus 3 is by darn 12. Because x minus 3 is 12, the absolute value of 12 is 12, right? Okay. Or if x minus 3 equals negative 12. Because if x minus 3 is negative 12, you have the absolute value of negative 12, which is 12. Okay. Now you know how to add 3 to both sides. So I'm just going to write out the fact that it's 15. And we can add 3 to negative 12 and get negative 9. Which is at negative 9, 15. That makes sense? If the absolute value of something equals 12, then whatever's in here has to either be 12 or negative 12. That's all there is to it. Now I'm going to write out this one, and I'm going to write it out same logic as we have here, but I'm going to write it out in a little different format. Here we have it. This means that obviously, if you think about it, the absolute value of 2x plus 5 is 12. If 2x plus 5 is negative 12, because we have the absolute value negative 12, it should be 12, or 2x plus 5 equals 12. Okay, and you can solve each of these equations. So here you get 2x equals negative 17, x equals negative 17 over 2. Okay. If x is negative 17 over 2, you can plug that back in here. 2x would be 2 times negative 17 over 2, which would be negative 17. So you have negative 17 plus 5. Negative 17 plus 5 is negative 12. The absolute value is 12. You need to do that check. If you're doing these without checking, you never know if you're doing them right. You just open math likes your answer. Okay. So the check helps you understand what you're doing. And I keep emphasizing you need to check your work. You learn more. And you'll learn it faster, even if it takes you a little longer to do each problem. You won't have to go back and relearn it when it comes time for the test. At least you won't have to spend as much time relearning it. Okay, well, you easily solve this equation. You get x equals 7 halves. And you plug in 7 halves. 2 times 7 halves is 7. So you got 7 here plus 5 is 12. Absolute value is 12. we can use the graph to visualize what we're doing, okay? So we can sketch a graph of the absolute value function. I'm going to use a small square here. There it is. Okay. So basically our 4x4 square with the red dot here. Of course, now I can extend this thing and do a very good job, but there it is. Okay. There's the absolute value function. We want to do absolute value of x equals 12. We sketch the line y equals 12. Function is y equals absolute value of x. This line is y equals 12. And we project down to the x-axis. Again, I drew this thing very poorly. I drew it so poorly. I'm going to point it out. Just take a second. There's the picture. It still isn't symmetric, but you can pretend it is. Okay. You can draw a better one. Chimpanzee can draw a better one. Okay. So this shows you that y equals 12 if x equals negative 12 or 12. Okay. Okay. Now I'm going to use that board I just saved. I don't want to apply any more than the board than I have to. Excuse me. Okay, I'm not going to be able to get enough of this on there. Okay, so we're going to redraw y equals absolute value of x. Now I want to draw, well, I want to solve the equation excuse me, something there. I want to solve the equation absolute value of x minus 3 equals 12. How am I going to do that? Okay, well, this is the y equals absolute value of x function. How do I get y equals absolute value of x minus 3? Well, I'm replacing x in the absolute value function by x minus 3, right? Means I shift the graph 3 units to the right. If you replace x by x minus h, you always get the graph of x minus h, okay? So here's 4, so here's where x equals 2, here's where x equals negative 2. X equals 3 is going to be about here. So the red dot is going to move to the point 3, 0. And now I Sketch a square, and there's a graph of y equals absolute value of x minus 3 with the vertex, you want to call it that, at 0.30. Well, this means that I can draw a bigger graph so I can get out to x equals 12, or y equals 12. I draw the same thing like this with my 4x4 square here, and extending this. Still y equals absolute value of x. And now my scale is bigger because right here is 4. So here would be like 8, and here would be like 12. I draw the line y equals 12, and then I move 3 units to the right. X equals 3 here. And I sketch it right out kind of badly. And I can see where my values of x are. Okay. So just illustrating the process. Not going to go into too much detail because the graphs aren't really drawn all that well to scale. But if you draw the graph well to scale, you can use the graph of y equals absolute value of x minus 3 to estimate the solution. Let's see what's really going on. Why you get 2 solutions. You get a solution here, you get a solution here. They aren't quite in the right place. This should be out at 15, which is kind of reasonable. This should be at -9, and it's nowhere close to that. The thing you can see from the graph is you always get 2 solutions. Okay. Unless you land on that vertex. Okay. Okay. Ask you to stop. Come on, stop. I don't know how much of that recorded, so I'm going to say it again, but go ahead and do what I ask. Okay, somehow something wasn't recorded. Let me just go back to this. We've got this graph here. We've got these 3 points labeled. This is a shift of an absolute, this is a transformation of an absolute value function. And the fact that this point is -2, -3, and this is 0, -1, we easily calculate that the slope is 1. So we know we haven't vertically stretched or compressed the absolute value function, whose positive slope is 1. Okay, so positive slope is 1. This is a shift, no stretch. The shift is h equals -2 units in the horizontal direction and -3 units in the vertical direction, because the basic absolute value function, toolkit absolute value function, is a vertex at the origin. To get the vertex down here, you got to shift it 2 units left and 3 units down. So h is -2, k is -3. Now your toolkit functions f of x equals absolute value of x. It's good to write that down so you have a reference when you've got to figure out what f of x plus 2 is. Okay, now why do you have to figure out f of x plus 2? Well, if this function is now g of x, and I write y equals g of x up here, indicate that this is g of x, that this function should match this one. G of x is f of x minus h plus k. That's always the case if you shift a function h units in the x direction, k units in the y direction. Now, if there's a stretch, you got to do that first. So that changes the function you're shifting. But there it is. We have no stretch. This one's simple. Then we just plug in h and k, -2 for h and -3 for k, and we simplify it. X minus -2 is x plus 2. Adding a -3 is the same as subtracting 3. And it comes down to the question of what's F of x plus 2. And that's what I asked you right now. So let me just kind of circulate around, see what I need to say next. Okay, not many people got this. So we really kind of need to talk about this because it's something we've done a number of times, okay? And what's F of x plus 2? What's F of aardvark? Well, x has been replaced by aardvark. So we have to replace x by aardvark. How many times have I said that? And how many times have you really understood it? Not blaming you or anything, but we can only say this so many times. So really focus on this, okay? You really need to get this. And I'm not sure how everybody did as well with the composites as they did if they don't understand this, okay? And it's obvious. I think maybe just a little weird because it's an absolute value, not an x squared or 1 over x or something like that. But it's a general principle. It's just what you always do. If I want F of any aardvark, that means I've replaced x by aardvark, so that's going to replace this x by aardvark. Okay. And this is something we really need to get straight, or we're not going to understand the transformations, which are really fundamental. Okay. So anyhow, there's F bar. Okay, so what is F of x plus 2? Can I ask you to just write that down and see if you understood what I just said? Because it's not easy. Okay. And every time it's a different function, it seems like it's different, but it isn't. You're just replacing x. Okay, so, I mean, we got f of x equals the absolute value of x. We don't have to do the and if we want to see the pattern. But if you replace x by x plus 2, you got to replace this x by x plus 2. Well, this x has absolute value signs around it, so you better have absolute value signs around what replaces x. Now, I've seen a couple that have like an absolute value of x plus 2. Well, it's easy to think that, but if you really think about what you're doing, you know that if x plus 2 goes where x is, the absolute value sign is not going to go there. It's going to, okay? Now, I recommend that you write it out. Write out your function. And then write out what you're taking the function of. You've seen me do this dozens of times now. Okay, so it should be familiar to you, and you're less likely to make a mistake if you write it out very, very carefully. Okay, if you make a mistake, you just go down the wrong path, you don't get things right, and you don't develop the understanding, and you take a lot of extra time. Okay, take the time to write it out carefully until you're really used to it.